Good morning, boys and girls. Today we're going to learn properties of exponentials. There are three basic properties that we're going to learn. The first one is the product property. The product property basically says this: if we have log base b of a plus log base b of c, we can actually write this as a product, log base b of a times c. Okay? So let's do some examples of that. So for number 34, we have log 3 plus log 2. Okay? So in this case, a is 3, c is 2, and b is 10 because this is common log. So we can write this as log, common log, of 2 times 3, which is the same as saying log of 6. Excuse me. 36 is similar. It's just log base 3. Since we're adding, we're going to multiply the arguments, x times w. 38 would be log 5, 9 times 3, 27. Again, this is common log because it doesn't have a base. It has the understood base of 10. So this would be log base 10, or common log, of 5 times 8, 40. Now this looks a little bit more confusing, but it's not, because we're still adding each of these, which means we're going to multiply each of the arguments. So this will be log base 2, and then we're going to multiply 7 times 2x. That gives us 14x, times y gives us 14xy. And 44 would be the same thing. We'll have log, common log, because it doesn't have a base, it understood base of 10, of x times x plus 2. Alrighty, what I want you to do is I want you to pause the video, and I want you to do 35 through 45. Okay? All right, welcome back, and I will give you the answers. And here are your answers. For number 39, don't let that confuse you. So it'll be z times 2x times 4y. Again, we're going to multiply the coefficients. 2x and 4y is 8. And then we just write the variables because when there's nothing between two symbols, it means multiplication. Same thing for 41. 5 times 3 is 15, and then we had y squared. This one can be written in a couple of different ways, so I've written it in different ways, and that is your final answer. And then that's your answer for 45. Okie dokie, boys and girls. So let's look at expanding it. So when I expand it, see how my argument is being multiplied? I'm going to write this as the sum of two logs. So I still have log base 3 of 3 plus log base 3 of w. This will require 3 logs. So this will be log base 5 of x plus log base 5 of y plus log base 5 of z. Same thing for this one, log base 7, 2 plus log base 7x plus log base 7y. Now, don't let this fool you. Remember, natural log just has a base of e. So it's just like a log. It just has a base of e. So we say this is natural log of x plus natural log of x plus 1. Okay, boys and girls, pause the video and do 30 through 33. Okay, welcome back. And these are your answers. So that's it for the product property. Now let's look at the quotient property. The quotient property says this: if I have the log of base b of a plus minus, okay, I can't spell log, minus log base b of c, that's equal to, then that becomes a quotient. So that becomes log of a divided by c. Okay? So when we are writing this, I can write this first one as log, and my arguments are 3 and 2. So this would be common log of 3 over 2. Remember, common log has a base of 10. And then this would be log base 3 of x over w. This would be log base 5 of 9 over 3, which we could simplify to log base 5 of 3. This is log 5 minus log 8. Why did I do that? I don't know. And it's early in the morning where I am, so there's no telling what's going to happen by the end of the day. There we go. Again, that's common log. It has a base of 10. This one would be log base 2, 7, and then everything that has a subtraction sign would go in the denominator. So this would be 2xy. And this would be log x over x plus 2. Okay, boys and girls, once again, pause the video and try problems 2 through 12. Okay, welcome back, and here we go. I don't think there was any that were a little tricky. Okay, for 5, both the z and the 2x went in the numerator because there was addition, and then the 4y went in the denominator by itself. I think that was the only one that was a little weird. Okay, all righty, let's do our next one. Now we're going to expand. So this expansion would be common log 3 minus common log 2. And remember, common log has a base of 10. All right, this would be log base 3 of w minus log base 3 of x. The natural log of 9 minus the natural log of y. Natural log has a base of e. This would be common log 5 minus common log 8. This would be log 2 of 7 minus, now notice both of these are in the denominator, so I would have to write that as log base 2 of w minus log base 2 of y. And then this one would be log x minus log parenthesis x plus 2. Okay, all righty. Now I want you to try problems 2 through 12. Pause the video and come back and I'll show you what it is. Okay, welcome back. Here are your answers for 2 through 12. The only ones that were tricky, this one was, these two may have been a little tricky. X, Y, both went in the numerator and then Q in the denominator. For this one, 3 and X are in the numerator and then 4 and Z are in the denominator. Same thing for 10. Okie dokie. All right, last property, and that's the power property. And the power property says this. The power property says that if this is my favorite property. I like to call it the drop it when it's hot. So this says if I have log base b of a raised to the c power, then that c is going to drop and I get log base b of a. I like this one because this is the one we use most often when we are solving equations. And y'all know I love to solve me an equation. All right, so what's going to happen with this? So this 5 natural log has a base of e. So we treat it the same way. So we have x to the 5th, that 5 will drop. And that'll be 5 natural log of x. This has a power of 2. The 2 would drop. And this would be 2 log x plus 1. This has a power of power of x. So the x would drop, and I would get log base 2 of 2. Oh, this one we have to remember, we have to rewrite this as log x to the 1/2. So then the 1/2 would drop, and I would get log x. This one, because cube root is in the denominator, I have to write this as log base 2 of 1 over x to the 2/3, because that's my power and that's my denominator. But I don't want it in the denominator, so I will write that as log base 2 x to the negative 2/3. Then this negative 2/3 is going to drop, and we have log base 2 of x. Okay? All righty. So what I want you to do is I want you to pause the video, and I want you to do the problems 2 through 10 on the right. Okay? So welcome back, and let's see what we got. Notice when this x plus 1 drops, I have to put it in parentheses. That's important. And I had to rewrite some of these exponents. Okay? Alrighty, let's last one and then we'll be done. We have 3 log 5. So we're writing this, I said condensed. This is actually, well, yeah, it's condensing. We're going to write this by putting this in the exponent. So this would be log 5 to the 3rd. This would be log base 2 x to the 5th. This would be log base 3 9 to the negative 2, which can be written as log base 3 1 over 9 squared, which is equal to log base 3 1 over 81. Okay? This would be written as common log. What's the base of common log? 10. This would be common log 81 to the 1/2, which is the same as saying log square root of 81, which of course would be common log of 9. And this last one, again, it has common log, has a base of 10. We would write this as log 27 to the negative x. All right, boys and girls, if you would pause the video and if you would try problems 2 through 10, that would be amazing. All right, welcome back to the video. And these are the answers for 2 through 10. And there we go. This can be simplified. Because if I take the 5th root of 2, it's 2. So this is log, so I can write this as the 5th root of 32 raised squared. And so the 5th root of 32 is 2. So this is log 4. Okay, boys and girls, one last thing. Here are some properties that you need to know. They're based upon the properties that we got up there. The biggest thing is just recognizing them, okay? You want to recognize them as a property when you see it, and it could save you a couple of minutes. So for instance, anything log of 1, doesn't matter the base, the log of 1 is always 0. If the base and the argument is the same, then the answer is 1. If the base and the argument is the same and you're raising it to the x, whatever this x is also your answer. I like to number them so you can see. So 1, log base 27 of 27, that's the same as this one. Your base and your argument are the same, so we know that's 1. Log is common log of 10, so your base and your argument are the same. This one would be 1 as well. Log base 5 of 1 If you have log, it doesn't matter the base. If you're taking log of 1, it's going to be 0. Number 4 is the same as number 3. Your base and your argument are the same, so my answer is x, which in this case is 3. All right, this is like number 1. Your bases and your argument are the same. Bases and arguments are the same. Bases and arguments are the same, so your answer is the exponent. And this is the last one. So because this A and this base are the same, then my answer is 5. This one we don't see that often. Okay, boys and girls, that is it for properties of exponents, and we will work on some examples tomorrow.